Alright, so today we're going to go through a little bit of review. We're going to talk about a couple of things. Okay, first we're just going to review a couple of problems from last night. So here's the first one. What type of function is this? Alright, so let's go straight through. And first we're going to look at the differences. And so I'm going to go ahead and go -1 minus 8. Now, if you have a hard time with negatives, you need to be honest with yourself and say, I have a hard time with negatives. And you need to write it out. -1 minus -8 is the same thing as -1 plus 8, which is 7. Okay? 0 minus -1. It's always the second minus the first. 0 minus -1 is +1. 1 minus 0 is +1. 8 minus 1 is 7. Alright, so the first differences are not the same, therefore it's not linear. Alright, let's try the next one. Let's go to the next set of differences. So I'll do 1 minus 7, which is -6. I'll do 1 minus 1, which is 0, and I'll do 7 minus 1, which is 6. This is not quadratic. So let's try our last one, which is looking at the ratios. And so I'm going to do -1 divided by -8. Now I could do that as a decimal if I really wanted to, but I'm just going to write it as 1 over 8. Now negative divided by negative is positive, therefore it's just 1 over 8. 0 divided by -1 is 0. I don't need to do the other two because the ratios are not going to be the same. And so it's not exponential. In fact, this is what we call cubic. If you were to do the third difference, you would find that the third difference is finally the same. But that's not in the scope of this course. You don't really have to worry about it. So let's just go on to the next piece. So what exactly is domain and range? Well, domain, of course, are the x values. Right? Domain are all the x values, all the inputs that are allowed to go into a specific function. All right? Now, when we find the domain, one of the best ways to do it is focus on the maximum and minimum x values. Now, where I see a lot of people get confused is they start to look at the graph going up and down. The up and down don't matter for domain. All that matters is the right and the left. Does the graph keep going to the right? Does it keep going to the left? If not, then we need to restrict it. The up and down have nothing to do with domain. The other thing we're looking for is maybe x values that possibly can't work. Now at this point, none of the functions that we have will contain that, unless you're thinking of like a real life situation where a negative number doesn't make sense, or where it's impossible to weigh 1,000,000 pounds, or I don't know what the situation could be, but you actually have to think about the problem. I know, think. Oh, Mr. Bow, what are you going to make me think? Yes, you got to think. Alright, so what is range? Well, range is exactly the same thing, except it's with the y values. So it's all the outputs that are possible. So we want to look at the maximum and the minimum y values. So what's the highest point? What's the lowest point? In between, it doesn't matter what happens as long as it doesn't go above the maximum or below the minimum. If it does go above the maximum, then I need to change my maximum because it really wasn't the maximum. I have to change it to whatever the maximum really is. Again, all the stuff in between doesn't matter. How far it goes to the right doesn't matter. How far it goes to the left doesn't matter. All that matters is how high it goes and how low it goes. All right? So let's take a look at some of these. What are the domain and range of this function? All right, well, let's look at domain first. So domain is the right and left. So I like looking at positives first, so let's look at the graph. Does it go to the right? Yes, you can see this arrow right here. It keeps on going to the right and to the right and to the right. Now, the fact it goes down does not matter. The down has nothing to do with right and left. So it's going to the right, 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 right. Does it go to the left forever? Well, no, because it stops. Well, where does it stop? It stops at x equals -1. The point is not important. The x value is. And so it stops at -1. And so it's everything from -1 to the right. So how do I show that x is everything from -1 to the right? Well, I say x is greater than or equal to -1. And that's my domain. All right, how about the range? Well, the range, again, is the y values. And so we're going to look at the range. Okay, does it go up and up forever? The answer is no, it doesn't go up and up forever. If there was an arrow on this end, then yes, it would. But this one doesn't. It stops right there. This is its maximum. That's the highest it goes. That's the most upwards that it goes. Now, going down, it does go on and on forever. So it keeps going down, 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 down. So there is no minimum. but there is a maximum. What is that maximum? What's the highest point? Well, the highest point is a y value of 3. And so that means that y is bounded by 3, and it's going to be everything that's less than or equal to 3. Again, we're just looking at the up and down. Is there a vertex? No. A linear graph will never have a vertex because it's just a straight line. It won't ever turn. It won't change. Is there an asymptote? No, because the line does not get closer and closer and closer to a number without quite ever reaching it. Asymptotes require that you go out to infinity, that you get closer and closer, but won't ever reach there, even if we go all the way out to infinity. Is there an x-intercept? Yes. Can we tell what it is? No, but it is that point right there, whatever that is. Y-intercept? Yes, there's a y-intercept right here. We don't know what it is because we can't see the values. I would assume that it's probably 0, 2. And 2, 0 would be the x-intercept because it looks like it's about 1 down from the 3. But let's go on to the next question. Let's see what we can do with a little bit more domain and range. Okay, so what are the domain and range of this function? Let's do domain first. Does it go to the right forever and ever? Why, yes it does. Does it go to the left forever and ever? Why, yes it does. What does that mean? It means that x can be anything of the set of real numbers. You say, but doesn't it stop here? Well, going to the right and left? No, it doesn't. Domain is just the right and left. It's not the up and down. All right, so range is up and down. It goes up and up forever, so it can keep getting bigger and bigger. Does it go down and down forever? No, it stops. Eventually, it stops right here at a y value of -1. And so the y values will be greater than or equal to -1. Is there a vertex? Yes, there is right here. That's the absolute minimum. Is there an asymptote? No, quadratics do not have asymptotes because it actually reaches that point. Is there an x-intercept? Why, yes, there's 2 of them, Mr. Bywater. There's 2 right there. I see 1, I see 2. Yes, yes, yes. Is there a y-intercept? Yes, the y-intercept is right there at 0, 0. All right, let's go on and look at another one. Here we go. What are the domain and range of this function? Well, let's look at the domain first. Look at the right and look at the left. Does it go to the right forever and ever? Why, yes, it does. It does. It goes. It doesn't matter that it's going up. What matters is that it continues going to the right. Okay, does it go to the left forever? There's a point. It stops. There's not an arrow, which means it needs to stop there. All right, so how far to the left does it go? To the -4. So x can be equal to -4, or it can be anything to the right. It can be anything bigger than -4. And so there we go. That's our domain. How about range? Range is only the up and down. You say, oh, well, here's... Holy moly! You say, oh, here's a maximum, Mr. Bywater. Is that really the maximum? No, because look, it goes up. It goes up farther. This doesn't really matter at all. We don't really care about that. Okay, because it does keep going up and up and up. Now, this isn't really a minimum either. It's a relative minimum. It's lower compared to the stuff around it, but this is the lowest point. All right? So the lowest point is -3, and from there, it can continue going up and up and up. And so we're going to say y is greater than or equal to -3. Is there a vertex? Why, yes. In fact, there's 2. There's one here, and there's one here. Those are both vertices because they're both turning points, relative maximum minimums. Is there an asymptote? No, this is not an exponential, so it doesn't have an asymptote. Is there an x-intercept? Why, yes, there are 3. Holy schmanoles, there are 3 x-intercepts, and there is 1 y-intercept. Now, obviously, right now, we can't tell exactly where those are, but at some point, we'll teach you how to do that. All right? Okay, let's do another one. Here we go. What type of function is this? Back to the function types. So let's try differences. Let's go 3 minus 1.5 is 1.5. 6 minus 3 is 3. 12 minus 6 is 6. And 24 minus 12 is 12. And then we can try these. The first differences weren't the same. So let's go for the second one. 3 minus 1.5 is 1.5. 6 minus 3 is 3. 12 minus 6 is 6. Okay, so that doesn't work either. Let's try the ratios. 3 divided by 1.5 is 2. 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. Alright, there's a constant ratio. This is exponential. Let's go on. Alright, what are the domain and range of this function? Alright, let's do domain first. X values, does it go to the right forever and ever? Yes, it does. Does it go to the left forever and ever? Yes, it does. That means X is of the set of real numbers. Let's look at the range. Does it go up and up forever? Yes, it does. Does it go down and down forever? No, because this, remember, is an asymptote. And as an asymptote, it will get closer and closer to 0, but it will not ever get there. And so there's a boundary here at 0. We like to draw this asymptote sometimes as a dashed line to show that it isn't ever going to cross that. And so y can be anything above 0, but it can't be below. It can't be 0 either. Remember, we just said that it will never actually reach it. So y is going to be greater than 0. Is there a vertex? No. It does bend, but it's not actually a turning point because it doesn't start going up again. Is there an asymptote? Yes. The asymptote is at y equals 0 because that's the number it's getting closer and closer to without ever reaching it. The x-intercept, it won't ever reach the x-axis, so there's none. The y-intercept is right here, which you'll notice is at 1. Each of these hash marks is a half. Alright, so there we go. Let's do one last graph and then two last tables. So here we go. The domain and range. Domain, does it go to the right forever and ever? Yes. Does it go to the left forever and ever? Is there any reason why I can't put an x value in there? The answer is no. So x is of the set of real numbers. How about the range? Range, does it go up and up forever? Why, yes it does. Does it go down and down forever? No, because it's got a turning point right here, and so there's a boundary. That turning point is right at 0, and so in this case y can be greater than or equal to 0 because it does go up and up. It never goes down below, so it can't be anything less than 0, but it will actually be 0 at that turning point. Is there a vertex? Yes, right here at 3, 0. Is there an asymptote? No, that's only for exponentials. Is there an x-intercept? Yes, it happens to be the same point as the vertex, the 3, 0. And the y-intercept is 0, 3 right here. Sweet. Moving along, we got two tables left. Here we go. We're going to try the differences. 4 minus 2 is 2. 6 minus 4 is 2. 8 minus 6 is 2. 10 minus 8 is 2. Does this mean it's linear? No, look at those x values. Are those ascending in order one by one? No, they're not. They're jumping all over the place. -2, 5, 0, 1, -3. These are completely out of order. You can create whatever type you want if you just move things around and put them in the wrong order, but that doesn't make it a linear function. And so therefore, no, this is going to have to be some other type of function because this will not end up being linear if you rearrange these and put them in the correct order. Alright, so let's go to one last one. Here we go. Let's try differences first. 6 minus 15 over 2. 15 over 2 is 7.5. So 6 minus 7.5 is -1.5. 9 over 2 is 4.5. So that minus 6 is -1.5. 3 minus 4.5, again, is -1.5. And 3 halves minus 3 is, again, -1.5. This one is linear, because as the x values increase by 1 at a constant rate, you have a constant ratio, a constant difference of -1.5. Hope that was helpful. Hope you got those questions right. Ciao.